Okay, question 2 said to make a graph. So I'm going to look at my 2 points on my t-table and I'm going to sketch a graph. And you could always use graph paper as well. So I'm going to make a y-axis and an x-axis. Oh, I hope that's going to be tall enough. I can go up a little bit more if I need to. Okay. So, and I'm going to see what are my 2 points that I'm trying to get so I can make my scale. So I know x has got to go from 0 to 10. And actually I know that it's going to keep going a little farther. So I'm just going to continue to count by ones like I did in the first place. But since I'm trying to get all the way up to 52,000, I'm going to think about what I'm going to count by there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's a good skill to practice trying to make even spacing, and not worrying about if it's going to be perfect because it's a sketch. And if I'm going to count by 10, if I want to count by 10,000s, I think that would work well for me because I'm trying to get to 52,000. So 10, 20, 30, 40, 50, 60 is high enough because I only need to get to 52. So 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. And here I go. So one of my points is, let's remind you, when x is 0, g of x is 52,000. So think about where that would go. A little bit above 52, not all, I mean a little bit above 50,000, not all the way to 60,000, so about right there. And then my other point is at 10 minutes. Take a look here. At 10 minutes, we have a total of 28,000 gallons in the pool. At 10 minutes, we had a total of 28,000 gallons in the pool. So 10, just going to kind of go like this so I know where I'm going. 28. Is it closer to 20 or 30? It's closer to 30, so about right here. Okay, so that's an estimate, and this is going to have to go farther for us to get down here. So if I just take a piece of paper and I sketch a line through those 2 points, I'll have a graph of g of x. And this is going to help us later figure out the domain. We're going to have to figure out what this point is at some point. But let's label the 2 points we have. This is 0, 52,000. And this point here is 10, is the input or the independent variable. And the output was 28,000. That's how many gallons were left in the pool at that point. Okay, there's our graph. And that's the graph of g of x. And we already did. So this is problem 2. And we already did problem 3, which was figure out that it is. I'm going to write it in the way that makes sense from the information. We start with 52,000 gallons. And we take away 2,400 gallons per minute. And now I'm going to look at number 4. And number 4 was asking about the algebraic way of adding them. And what that is that's just combining like terms, which you've been doing since middle school. So we're going to take our 2 functions, d of x, which if you remember was, he started with 24,000 gallons and he took away 1,000 gallons per minute. And a of x, okay, you might notice I'm writing these in a different order. I'm writing b plus mx. And that's because I'm thinking about the water as I'm doing it and showing you that you could write it either way. As long as this is addition right here, you could change the order either way. So we had 28,000. Allie's pool started with 28,000, and it decreased, if you remember, by 1,400 per minute. And you could look back and see that that's what it was. And so if I'm just going to add these, just adding, like you just add anything, I add my constants together and I get 52,000. Okay, I add my x terms together. It's just like adding anything else. They could be Baby Ruth bars. Negative 1,000x plus negative 1,400x. It's easy to add those. They're all negative, so it's just a negative answer, and we add it all up, negative 2,400x. And yes, if you look back to our equation that we wrote in problem 3, and I copied here, this is g of x. Okay. So yes, they do come out the same, and that certainly makes sense. So the reason we're doing this is that there's two different ways to show what it means to add functions together. Okay.